Okay, good morning, class. I hope you are having a good Tuesday. What I'm going to do right now is go over the PowerPoint with you so you understand your assignment. I did go over it with you yesterday in class, but as I am not here today, I wanted to give you this information. You should have on your desk the fill-in-the-blank notes that go along with this PowerPoint. You do need to complete this bell ringer right here. You need to define the following words: thermal energy, latent heat, conduction, convection, radiation, food chain, and food energy. Once you do that on your own paper, please turn it into your tray. So today we're going to talk about energy. It is very important, especially in food science as it relates to food. This is how we cook food. This is what we do with food whenever we're transferring energy to heat. This is how we change food. So it is going to be very important for you guys to know. Energy is the power to do work. Potential energy is stored energy of position, and kinetic energy is energy in motion. These right here are some examples of potential energy and some examples of kinetic energy. You can kind of see the difference between the two. Your digestion system is actually considered chemical, therefore it is a part of potential energy. Okay, so this kind of helps to show you what and how it relates to food, because we have the chemical digestion here. Okay, electrical energy, the light bulb. If you ever used an easy bake oven, that's what kind of energy you used. Electrical would be like your ovens and your stove tops. Thermal would be fire if you've ever gone camping. Okay, that's the kind of fire you would, or the type of energy you would use. Energy in food. Thermal energy. This is the most often used energy source in food science. That is extremely important for you to know for your next exam. Okay, the energy transfers from one body to another, or one thing to another in this case, and it's triggered by a temperature variance between the two. So this down here, this is the formula. You do need to fill it in on your notes. I am not going to necessarily ask you to remember that formula. If I do need you to do anything with it, I will always provide it to you, but it is important for you to fill in your notes if that's an option on your notes. The calorie, this is the amount of energy needed to raise the temperature of 1 gram of water 1 degree Celsius. The kilocalorie, which also means 1,000 calories, is the unit of measure that indicates the amount of stored energy in food. This is how things have calories, and this is why a lot of people watch calories. The joule, the metric measurement of heat energy, equals 0.239 calories. Okay, so both of these are important for you to know. You do need to know those definitions. You will see those again. Heat and matter. We talked about last week about water. Okay, this again kind of relates to that a little bit too, because it further shows you how heat can change things. Okay, so molecules are always going to be in motion. With gas, the molecules are completely unrestricted and travel straight up until they get stopped by something. That's what this shows you right here. Liquids, they're going to be more restricted and they bump into each other constantly. Okay, they do still have some movement though. And solids down here, they are the most restricted and they can only vibrate. They do maintain a definite shape. They cannot move around like liquids and gas can. Heat and matter, whenever the phase, doesn't matter, when heat energy is added, molecules speed up and expand. So by increasing the activity, you in turn increase the temperature. So here you can see, you have this line on your notes. Make sure you write this top part in. You have heat plus ice, which causes the ice to melt. It gives you liquid water, but as you continue heating it up, it's then going to get to boiling and turns to a steam. This further relates to what we talked about last week with water. Each substance requires a different amount of energy to raise the temperature of 1 gram of the substance 1 degree Celsius. This is known as specific heat capacity. That is a word you need to know. Okay, for example, down here, water, it will change at 1 calorie per gram Celsius. Iron is 0.11, glass is 0.20. What this means is each thing has its own temperature in which it will begin to get hotter. That's why it takes things different times when you put it in the oven. A glass pan is different than an iron one, or a metal one for that matter. So, for an example, this is what I want you to ask yourself. Which will get hotter the fastest, the iron pan or the water that's in it? Okay, take a few seconds to think about that. Also think about which will get hotter faster as well, a glass pan or an iron pan. It's all going to be dependent upon that heat capacity that we just talked about. So, to answer your questions, the iron pan will get hotter because it only requires 0.11 calories per grams degrees Celsius. The water requires 1. Okay, that's a huge difference. The iron is going to get hotter much faster than the water. Therefore, the iron pan is going to get hotter quicker than the glass pan. So your assignment for today, it is to create a poster. You can use the notes that you just filled in, okay? That's the main focus. I want you to use anything from the notes. Those are the words you're using. You're going to create a Wordler poster. It's going to look kind of something like this with a collage of words, but you're going to use it for today's lesson. For example, you could do your poster in the shape of an oven and fill in the words with the oven. And you could use words like conduction, convection. You could use energy, heat, temperature. Those are kind of words that I'm talking about. If you need examples, you can find examples on my door. If you look on my bathroom door, you'll see different pictures like a sun, a leaf, a kettle, a saucepan, an electric bolt, an ice cube. Okay, so it needs to be in the shape of whatever it is that you can think of. Be unique, be different, think out of the box. Okay, and then you're going to fill in that shape with all the words from today's lesson. If you have any questions, you can email me. That would be great. I can go over anything. I will be available to my phone, so if you do have any questions, email me. All of these assignments are due at the end of class today, so when I return tomorrow, I expect everything to be done and turned in.